Hello out there, awesome people on the internet. Thank you for joining me. My name is Gabe Hollenby. I am a technical evangelist here at AWS. I'm coming to you live from our office in Singapore. So good morning to everyone in my side of the world and good evening to everyone on the opposite side of the world. What we're going to do today in this session is cover the basics about deep learning. What is it? How is it that it does such magical things? And we're going to get into that with some hands-on practical overview of training our own custom image classifier using our tool called Amazon SageMaker. If you've never used SageMaker before, that's fine. If you have no idea what deep learning is besides something that makes computers do magical things, that's also fine. But hopefully you're here. Hopefully you are a coder. We're going to be looking at code. I'm going to be showing a lot of Python code today. If you don't know Python, that's also fine because the code is going to be pretty self-explanatory. There's no crazy Python wizardry going on. Should be pretty comfortable for you. So let me show you what our plan is for the next hour that we have together, and then we'll just jump right in. So what I'm going to cover today is just a quick overview. What is deep learning? Why is it cool? And then I'll show you an example of deep learning in action using one of our services called Amazon Recognition. Then I'll give you a quick overview about SageMaker, and then we'll get right into it and we'll start doing something cool and real with SageMaker to train our own custom image classifier. And we'll do that by collecting some images. Well, look, I have a typo in my notes. We'll do it by collecting some images and classifier. There. So we'll do that by collecting some images, and then we will train a model, and then we'll test out that model. And then I'll give you some examples of some customers who are using SageMaker to inspire you. Now, if we have more time, I'll show you some other really cool demos that I've done. I'll show you an image classifier I built that can detect extremely subtle differences between some things. It's really cool. I hope we have time to get to that. And I can even dive deeper into how deep learning works. Now, this is a live chat. Still spelled incorrectly. I know. Thank you. It's 8 in the morning for me and my brain isn't working right. Thank you, Hedge Gel, for calling me out. I just need to have more coffee. Classifier. Oh, that looks right. Oh, up here. Yes. Classifier. There we go. So let's get right into it. Point is, this is a live session. Please interrupt me in the chat if you have questions that you want answered. We also have moderators standing by who can moderate and answer some questions for you. If there's things that they can't answer or that they think are really good for me to address live on stream and I miss them in the chat, I'm also watching the chat on my laptop screen here. But if I miss them for some reason, I have someone in the room who will also poke me and say, hey, Gabe, answer this question. So please don't be shy. That's the whole point of this being a live coding stream instead of you just watching a video of me doing this on YouTube. So please take advantage of that. That's why I'm here. I'm here for you. So let's get going. Hey Mush, thank you for saying hello. And happy Red King Crab. I like that screen name. Yes, this is live, Terry. This is truly live. Yeah, like I said, it's 8 in the morning. That's how you know it's live for me. So let's get into it. What is deep learning, right? So at its core, deep learning sits in the broader field of machine learning. What is machine learning? Machine learning just means a technique that lets computers do things that are easy for humans to do, but hard to explicitly program for us developers. Some examples: self-driving cars, right? Sentiment analysis, right? Looking at my tweets and deciding how does Gabe feel about, the president of the USA? Although we could probably write that in code ourselves because that's a very easy rule. But, other more complicated things, right? Like looking at a big corpus of text and figuring out if people are writing positive or negative reviews. Harder stuff too, right? Like here's a picture of the Eiffel Tower. How do we know it's the Eiffel Tower? I have no idea how I could sit down with you and we could figure out how to write that in code ourselves explicitly. There's just too many possible permutations of, with the angles and the colors and of how we could analyze the pixels to figure that out. It's way too hard. So these, or face analysis is another example for deep learning, right? So these kinds of things are good examples of deep learning in action that fall into the category of machine learning. Now, there are other types of machine learning. Now, traditionally, and there's so many useful algorithms and techniques in the machine learning field that don't rely on deep learning. And those techniques require a step in your process where you've got some data and you want to teach your computer how to do something with that data, right? How to learn from it. And usually there's this step where a human being explores the data, looks at it, tries to understand it, and tries to figure out what are the salient and relevant features of that data that we should call out explicitly to the computer and say, here, computer, look at these 10 things about the data. And from these 10 things, build your model and decide, what's what. That's called feature engineering. That's just some jargon for you. Now, the cool thing about deep learning is we don't need to do feature engineering. You just give the raw data to the computer and say, here's kind of what I want you to figure out how to do, right? Usually we use something called supervised learning in this case, where we're giving it examples of, here are the things I want you to recognize, right? And like, these are pictures of a face, these are pictures of a cup, etc. And it will try and figure out what are the salient and relevant things about photos that make cups and that make faces, etc. So we don't have to do the feature engineering. It cuts out a huge step from the traditional machine learning workflow. Let me give you an example of this in action. Okay, cool. So here we have one of our services called Amazon Recognition. Amazon Recognition is really cool. It has a couple of different APIs associated with it. It can do things like recognize celebrities. It can look at text inside of an image, etc. But the thing that's kind of most analogous to what we'll do today is this. You give it an image and, like, for example, let's switch it. Let's look at this one of just a cityscape. You give it an image and it says, yes, look, I think I'm 99.1% certain that you gave me a picture of a city, right? Or a building or town or metropolis. There's high rises here. So how does it do that, right? It does it because Amazon, AWS, we trained a deep learning model with a bajillion, which isn't a real number, but that's because I don't know the exact number, right? A whole lot of images in different classes of things. And from that, we got a pretty robust model that recognizes all kinds of things. But people come up to me when I show them recognition, they say, recognition is great, I love using it, but I also want to be able to recognize things that are specific to my domain and my business that recognition doesn't yet know about yet, or maybe not at a level of specificity enough yet. For example, if I put a picture of a sparrow into recognition, it'll say sparrow, but what if, so I'm a bird nerd, I like going bird watching. So, what if I wanted it to tell me what species of sparrow it was, right? Recognition doesn't have that level of granularity into it. Well, the answer that I can give you today is just train your own image classifier for what you want. It's actually really easy, and that's what I'm going to show you how to do today in this stream. So hopefully inspire you to go and build your own things and to learn more about deep learning and what you can do with SageMaker as well. And SageMaker can do way more than just make image classifiers too, but that's one thing. It makes for a good demo and a nice introduction, so that's why we'll do that. So there's deep learning at work. Let me now show you instead SageMaker. So this is just a service page for SageMaker. It gives a nice overview on what Amazon SageMaker is, how it works. The key points about it are SageMaker makes it very easy to do the three things that you want to do during machine learning model development, right? Building models, collecting and preparing your data. So for that step, we have a tool built into SageMaker called a Jupyter Notebook. If you already use Python, you're probably familiar with Jupyter. If you're a data scientist, you probably are too. But for those of you who aren't, Jupyter Notebooks Jupyter's just a tool, an open source tool that gives you a nice web interface to interactively run Python code and see the results. You can visualize things about your data in it. You can run little bits of code, etc. And you'll see that in action in a minute. So SageMaker will host a Jupyter Notebook for you on a virtual machine in the cloud that's fully managed by AWS, so you don't have to worry about it. And it comes preloaded with all of the, I shouldn't say all, but all of the deep learning and AI and machine learning things that I've ever needed. We took all of the stuff that customers have said, the common libraries in Python for this and for that, image processing and doing, scientific computing and it's got pandas and scikit and numpy and all that stuff. So all of that's built in. in a way, and all packaged together in a way that works really well. So we can start a SageMaker notebook instance. From that, in there, we can then get our data ready, and then we can train our model. So training our model, there's a few different ways we can interact with SageMaker, but at the highest level, the easiest way to interact with SageMaker is to say, I want to use one of the pre-built algorithms, right? So this is great for people like me. I'm not a deep learning expert yet. And so I'm not comfortable going and building a network myself. And I'll show you what I mean when I say network before we get into it. But I don't need to be, right? So for making an image classifier, we already have a built-in algorithm in SageMaker that knows how to do image classification. What that means is you just say, here's my images, here's that are properly labeled. SageMaker, go, make me an image classifier, and it will. And there's a number of built-in algorithms that I'll show you an example of some of the listings and how we know which ones we might want to use. So finally, after training and tuning that model, then we obviously want to deploy that model. We want to put it somewhere where other code can use it. And that can be a cumbersome process too, but it's not when it comes to SageMaker, because it's one click from the web console or even from the code. I'll actually deploy the model from the notebook using one line of code. And that makes a fully managed, secure, auto-scaling service that handles that for me. So it takes my model, puts it behind an HTTP endpoint that I don't have to worry about managing or scaling or anything like that. So that's really nice too, right? I make my model, I say host it, and then I can throw data at it from my other apps. I'm just checking the chat here to see if there's anything I want to address. Not yet. Can SageMaker accept audio files for training, says Soundmaster AJ. I don't see why not, right? Data is data. So depending on whatever algorithm you're using, you should be able to. I've never used audio files for training, but again, data is data as far as deep learning networks are concerned. And we have a service called Amazon Transcribe, which takes what you're speaking and turns it into text, and it can even do it in near real time with a streaming API as well. That's all built with machine learning as well. And so the technology exists to do that. You'd have to look into a little bit more to see the particulars about what algorithm you should use for doing real, audio processing. But you can absolutely, data is data, right? It's all numbers at the end of the day. So let me now show you how we would know what to do with SageMaker. So if we go to the docs, right? So this, I just bookmarked this, but this is just the default documentation for SageMaker on our website. And it tells you, if you're a first-time user of SageMaker, you can see more about how SageMaker works. You can read a Get Started guide. We have a lot of built-in examples, and I'll show you some of those later. But what you can see here is there's a number of links to get you started. So you don't just have to go off what I'm telling you today. The documentation here is really excellent and has a lot of helpful tips and pointers for where to go to get started. So with that in mind, let's start using SageMaker. Let's open a notebook instance. Let's start looking at some code. So I'm going to go back to AWS. I've already logged into my web console here, and I'm going to go to SageMaker in the console. And you'll see there's a number of things on the left-hand side. I'm interested in making a notebook instance. So I will go to notebook instances, and we'll make a new one here so you can see it all from scratch. I'll call this Innovate 2019 first stream, because I'm going to do another session later today for people on the other side of the world. Well, later today, my time. It'll be tomorrow for them. So we'll call that my notebook instance, and I'll say create. And it's going to ask me a couple of particulars about, oh, that wasn't me typing the name, that was me searching. Let's do this again. Innovate 2019 first stream. Okay, what instance type do I want? So this behind the scenes is using an Amazon EC2 instance type. So that's just a virtual machine in the cloud. A T2 medium is a really small instance. It's not very, very powerful. It's probably enough for what we want to do here today. I can also pick something more beefy if I want. It's really up to what you think your needs are in terms of the CPU power or the GPU power. Now, a key point I want to put out is when you are working with deep learning, you probably know that this all is powered by GPUs. When we train our models, we use graphics processor units for that. And that's because they're much better at crunching the kind of data, massive amounts of numbers and doing a lot of math really quickly than your CPU is. You don't need to have a GPU-powered notebook instance. So I'm going to stick with a T2 medium instance type here to show that to you. There's a number of other settings here I don't have time to get into, but you can learn about them later. Elastic inference, for example. But I'm not going to put this inside of a VPC. This is just going to be a notebook instance that stands on its own. I could say how much additional disk space do I want for this this instance. I'll say give me 20 gigs. And this is really cool. This is a new feature in SageMaker. I can say I have a Git repository already that has a Jupyter notebook instance that I want to work with. And I've already added it to SageMaker via a different tab down here on the bottom on the left-hand side. So Git repositories. So because I've already done that, and it's really easy to do, I can pick you'll notice I made a typo. I called it GitHub instead of GitHub, which is a typo I like so much I decided to keep it. I have a repository here already set to go. So I'll say, please load this repository into my new notebook instance that it's creating for me. And then I just click this create button, and I'm going to wait a minute. And while I'm waiting, what this is going to do behind the scenes is, again, provision a T2 medium instance for me, clone that GitHub repo into that instance, and then I can click on one of these links to open a Jupyter Lab notebook, for example, and get going with some coding. Now, while we're waiting just a few minutes for that, let me show you some of the example notebooks here. So I'm going to open an existing instance I have just to cover that for you while we're waiting, because it'll take like a minute or two to get me that instance ready. Oh, I've already got it open in another window. So let me close this and I'll move it here. Right, okay. So in the Jupyter notebooks that we spin up from the beginning, you'll see there's a special icon here on the left-hand side in the sidebar that looks like a little brain. It's a little SageMaker logo, and it says a collection of SageMaker sample notebooks. So if I click on this, without having to know a whole lot, I've got a number of notebooks already available to me that I can look at to see how do I do things. Like these are fully, yes, Mazgul, I will give you the repo link at the end of this, but I guess I could paste it in now too if you want to follow along now. So stand by 1 second, I'll paste that repo link in for you. Give me 1 second, let me just pull that up. So my GitHub username is GabeHollenby-AWS, and the notebook instance or the repo that we're using is my Jupyter notebooks. So let me paste this for you into the chat. Oh, look, I'm not logged into the chat here, so hang on. Let me just log in. You can't see this. I'm doing this on another window, you guys, so thank you for bearing with me. Let me rejoin. Here, hang on, guys. Give me a second. I'm going to log in off screen. I'm sorry, I thought I was already logged in when I was watching the chat, but I definitely want to make sure you have the repo link so you can follow along. Yeah, look, there, I am logged in. Okay, there you go. Let me pop this chat out again and maybe that'll work better. Cool, I hope that worked and that you guys can see that chat. So moving on, now that we've got the repo already posted. Also, I did have to re-log in again, and so I think there was a message in the chat of somebody who asked me to please address something, but I've lost that message when I refreshed my window. So I'm going to ask Ash, who's sitting next to me, to let me know if that's something that she wants to interrupt me for.
That's okay.
It's all good? Okay, already addressed. Good. Cool, we'll come back to it. So you can see there's a number of example notebooks already made here. So for example, things like, maybe I want to do image classification. So I can see that look at how many different notebooks there are here. And that's because they show different ways to do things. There's things using our feature called elastic inference. There's things using our feature called Neo, and you can look at the docs to see what those are. There's a notebook that says how to do multi-label classification instead of a single label classification on images, right? So quite detailed examples. Here's object detection. That's different than image classification because it'll say where in the image a particular thing is. There's other things too, right? Like here's something here that says XGBoost. Okay, Gabe, fine. What is XGBoost? How do I know that I would even want to look at that, right? That's probably a question you might ask. The answer to that is, if we look in the docs, if you could look in the docs and you see here, we have a number of built-in notebooks. So let's go to build a model, and we can say use built-in algorithms. If we look here, the built-in algorithms will tell you, how do you know which algorithms you might want to use from what SageMaker already has built in? And there's this lovely handy guide here, right? So it'll say, if you want to train a model with answers that fit into discrete categories, then do this. For example, you can use XGBoost or linear learner. If you want quantitative answers, like based on the ROI from past mailings, how much money am I going to earn if I mail this customer? Then you can use linear learner with this, or the XGBoost you can use with this hyperparameter. Discrete recommendations, like how do I recommend movies to people, factorization machines, and then, so there's all that. And then it'll say, then there's some special purpose ones like image classification, etc. Okay. Aurora says, Gabe, can I predict images on the go? I don't know what you mean by that. Or so similar to web form, if you upload an image, can you submit? Yes, that's what I'm going to show you in my demo. I'm going to show you exactly that. So stay tuned for that. And Sunmaster, thank you. I'm glad that you're getting perfect info from this. So let's go back to my notebook instance and see if it's ready. It is. So we'll say, OK, open Jupyter Lab. I'll close this other one that I had open so I don't get confused. And what I'll get is a nice web interface here where I can look at and run some code. Now, while that's coming up, I know that what we're going to need to do is collect some images for the model that I want to train. And to do that, I wrote a little tool. So here, let me just pop open this notebook. To do that, I wrote a little bit of a tool, which you'll see here. I'll switch here now. So this is, I've got my webcam running here on my laptop, and I wrote a tool that will let me just like press enter, and every time I press enter, it's going to capture what's on the webcam and upload that into like a folder on S3. S3, of course, is our cloud storage service, stands for Simple Storage Service, and it's where we're going to put our data. It'll let you store virtually unlimited amounts of data. And so that's where we'll put all of our images here, and then we'll point SageMaker at that. So for example, I'll make a dataset name called Innovate 2019 first stream. I could call this anything. In fact, you know what? Instead of me giving the name, why don't I ask for someone from chat? What should we call this data set? I'm gonna take pictures of faces, of some markers here, and I have some soda cans. So can somebody suggest an example for or a name for what we should call this data set that we're gonna work with? I wanna take a suggestion here from the stream for that. Plume, no. SETI McSet face. McData. I like McData or face soda. Let's do face soda. Let's do face soda. Thanks, Mauerback. I think that's cute. Face soda it is. So face soda is our data set name. Okay, now for our first label, let's call this face. Okay, so now we're going to capture images of faces. So yay, I picked you. Yes, Mauerback. Okay, so I'm going to take 15 pictures of my face, and then I'm going to ask my colleague Ash, who's sitting off camera here, to come in, and we'll take a few pictures of her. So as you can see, they're coming through. Okay, did 16 pictures of me. Ash, come on in. I'm going to get off screen, and I'm just going to look here. There you go. Just look. Yeah, just keep looking there and just move around a little bit. Give me some that are close.
Is that okay?
Yeah, give some that are closer. Good. Turn to the side. Other side. Perfect. You're killing it. Done.
Awesome.
Thank you. Feel like Austin Powers. Yes, you're a tiger. Okay. I took too many because I want to do this with only a little bit of data, not a lot of data. So I'll get rid of this one too. So I want to show you that. Thanks, CK. Yes, perfect shoot. I want to show you we don't even need a ton of data in order to train this model we're going to use, right? That might be a misconception you have. It's certainly one I had, that before I started learning about this, I thought you need a ton of data in order to train a model. You don't. Okay, so that's faces. Let's do another one. Let's do markers. And I've got some markers that I had lying around in the office. So let me just get that doorway out of the frame. Okay. So we'll do some green ones. We'll do some blue ones. We'll do some red ones. Again, I wanted to have 30 of each. That one's kind of a bad one. I'll get rid of that one. Finally, let's do some cans of drinks that I have here. So we'll say soda. Soda. Yeah. Okay, there we go. All right, and I'll get rid of that one because that's kind of a bad one. All right, so there's our data set. We're done. We've got 30 images of 3 different classes here, and we're ready to rock. I'm just going to copy our data set name here because I'll need that in a minute on my notebook. Now, let's look at code. Thank you for bearing with me for a while. Let's look at code. So our first step is we want to fetch where our training data is. Our training data is going to end up in something like this, right? On S3, I've got a common prefix, and inside that common prefix, I've got folders for each class, like person or ship, right? In this case, it was face, soda, and marker. So my data set name is this, and my bucket name, which I have here, that lovely name, is where my S3 bucket that my tool is using is. So I'll run that cell. So I just set some variables. Next, we're going to import SageMaker and set some variables here that we'll need later on. All that's happening here is we're getting a role. This is a AWS IAM role. So this is the information about the SageMaker environment that it can use to call out to S3 in order to read the data. This session is just a stateful variable from SageMaker that will know things like it'll keep. What is it that it'll keep in here? I'll put into this, the session has things in it like how I'm going to convert or I'm going to say, take the data here and it's of this input type for SageMaker to see. You'll see us use this session variable later and it'll make sense. Finally, training image. Don't be confused by the word training by image here. This is not one of the images we were just taking with the webcam. This is a Docker image, right? So behind the scenes, SageMaker is powered with containers. So this is a container image that lives on our Elastic Container Registry, ECR. And this method here, getImageURI, where I say I want the image classification algorithm, the latest version of it, taking the region that I'm currently active in, will give me that, right? So here I can print this out for you too so you can see what I mean. All right, now before I run through the rest of this, I'm actually just gonna quickly run through the whole notebook because training the model is gonna take a little bit of time and I don't want to get stuck later while we're waiting a whole lot for this to finish. But I'll come back and I'll review all this code with you in just 1 second. I'm just going to kick off the training. Let me just make sure it gets at least far enough to kick off that. And hopefully it will. And then I will also kick off deploying the model. Cool. I want to check one more thing before we continue to make sure that I still have enough model instances. Let's just look and see what endpoints I have in SageMaker. Yeah, cool. I've got enough space. I'll leave that one up too. All right, we should be good. So let's go back and let's continue looking at the code. So we got this far, right? So here's the address of the image classification Docker container that SageMaker ends up using, and we'll need that a little bit later on, that variable also. So before we can train our model, we need to prepare our data a little bit. We want to create some files that will teach SageMaker about all of the images in our classes. Now, how did I know that? So here's a link to the documentation, right? I just looked. I said, in SageMaker, inside build model, in the image classification algorithm section, I read all of these things about how it works and including just the default page here. And it'll tell you, here's the kind of things it can accept. And you can see here, it accepts both record IO and image files for training the file mode. And it also will take something called LST. So we can train with image format or with record IO format. Record IO is a common data format that you'll see is pretty common for training machine learning models. You don't have to use record IO, but I wanted to show you how to create record IO files from just a collection of images, for example, because it's a good thing to know how to do. So I included that here in the notebook as well. So the way we do that is we use something called im2rec.py. It's a script that is pre-installed onto our notebook environment here. And what all this code is going to do is it's going to set some environment variables for me that I'm going to use a little bit later, and some bash scripting that I will call out to from this notebook. And as you can see right here, all we're doing is we're saying, hey, Python, in your current execution path, find me where you see this im2rec.py script, and save that into a variable, which we'll use later to invoke this script. im2rec is an open source tool. I have more information about it a little bit later too, and that I can show you. So what are we going to do? First, we're going to get our training images from S3. So we're literally just using the AWS CLI here, and I'm pulling down from this, from my bucket name inside the directory that my tool was uploading to. I'm just going to pull down the data set that I'm interested in. Then we're going to create our record.io files from those images that we put on S3. So we can see here, if we want to, we can look at the docs for record.io to learn how to invoke it, but I'll walk you through it right here. Basically, I told the notebook here, I want to run bash, right? So instead of just doing a quick one-liner, like I did up here where I had an exclamation mark to run one shell command, I can just say, for this cell, I'm not writing Python anymore, I'm running bash. So I'm going to go into our baster. I'm going to remove any existing rec or LST files that exist. I'll tell you what those are in a minute. And then first we're going to do two things. So if you read the docs for this for this im2rec tool, what it's going to do is create a record.io file from an LST file. So first you need to make an LST file. All a LST file is it's a file that says, it's like a manifest file. So it's a list that'll say, for this image located in this path on S3 is of class face. This image located in this path on S3 is of class marker, etc. So that it's like one big long manifest file that just says that, right? This image, this class, this image, this class. And so because I already structured my images in those subfolders, which is what im2rec wants in order to make the LST file, that's how you can get going and create that LST file that way. So we're going to invoke our im2rec script here with the -- list flag, which says, make me an LST file. I'm going to say recursive, so it goes through the subdirectories too. I'm saying pass through because I don't want it to do any resizing. My images are already in an appropriate size of 224 by 224. How did I know those magic numbers? It was in the documentation for image classifier, so I can show you that again later. The LST file is just a manifest file, like I said. It's just a file that says, this image is of this class, that image is that class, this other image is this other class. So it's just like it's putting metadata about each of your images along with a path to the image, so that when you train your model, it knows what images are of which class to train. Yes, exactly. It's exactly like that. It's the manifest that links the class to the image. Thanks, Nikki. So finally, when we train, it's important that we don't use all of our data for training. We want to keep some aside to validate the model. And what I mean by that is, the way training a model works is it's going to go and it's going to look at a bunch of data. It's going to try and form guesses about what each of those images are. In this case, this one's a cat. This one's a can. This one's a face. This one's a marker. And then it's going to see how it did. And it'll see how it did by saying, because we know what the class should have been because it was appropriately labeled. It's going to do this over and over again and tweak itself until it thinks it's getting really good guesses for those. Once it does, then it runs, so that does it on just the training set of images. Then it will try and validate that model by passing images through that weren't used during training. And you want you want these images separate because you don't want your model to effectively memorize what the images looked like and then not be able to recognize other ones too. And I'm happy to go into that in more detail with some visualization examples if we have time. I just want to get through showing you the demo first. So we'll keep 70% of our images for training and 30% for test. Then we will run im2rec again, and we will convert our LST files. So we get two files out of this line. We get a training one and a test one. And so after that, we'll take each of these files and we'll convert them into record files. So we ran this, and we can see we have face soda and face soda test rec and face soda train rec at the end. Train wreck, that's funny. So now we're going to upload these so we can train with them. So I'm going to get the bucket that SageMaker is going to be using to get its data from our session object that we created at the beginning. And I'm going to make some paths of where I want to put the training data and the validation data. By the way, these record files, these record IO, it's neat because it packages the data together in an efficient way for the model to train from. So it's one binary file that has all the images inside of it along with the classes in such a way that makes it's just optimized for training. So here are the paths I want to store it to. We'll make sure that there's nothing in the bucket already. We'll upload the data, these two files, to the bucket, and that's what we see here. Finally, we're just going to make a Python dictionary here in order to tell the model where the training data is and where the validation data is, right? So I have this data channels variable that says my train data will come from this, where we're saying SageMaker.session, S3 input. So we're using a method here to say, I'm taking data from S3 in order where to find the training data. Where did I know where all this information came from? It's in the documentation. It's also in the example notebooks as well. So it wasn't like I had to go hunting through a long time to figure out this. It's going to be the same for what you do pretty much all the time, so you can copy paste it. So now it's time to actually train the model. To train the model, we're going to say, where do we want the model to go on S3 when it's done building it, right? It's going to put the final artifact result on S3 somewhere. And there was a question here from Mechanism. Why do we need to make a rec file? You don't need to. SageMaker supports streaming images directly from S3 as well. I wanted to show you that, not because you need to do it, but because you might want to do it later, because it's a common data format for a lot of ML deep learning training. And I don't want you to be stuck later if you get to the point where you're like, yeah, I need to make a rec file now, and Gabe didn't show me how. It was because it's actually pretty simple. So I thought I would include it in the demo here. That's all. You don't need it, but it's good to know how to do, right? So I wanted you to have that tool. So here's what we do. We're going to say now, give me an image classifier. So this is going to be an instance of a SageMaker estimator using our training image algorithm, passing the role variable that we got from the beginning of this notebook. Here I'm saying I only want to train on one instance. This instance is, this variable here, train instance count. If I have a ton of data, like let's say I've got 1 million images, or not, that's not even that many, right? Let's say I have 1 billion images that I want to train on. I'm probably going to want to do this on more than one computer. SageMaker is awesome for a number of reasons. One of them is that I could just change this number right here. Instead of 1, I can say 20, and it will spin up 20 machines and distribute the training load amongst those 20 machines for me. I don't have to manage that architecture, that infrastructure, anything. I literally just change a number here in the API. It's that simple. So it's extremely powerful. You get that kind of truly elastic scaling to meet whatever your needs are for your training. So that's that. The next is, what type of instance do I want to train on? So we have a number of different instances. As you know, you don't have to train on an instance with a GPU, but I recommend it. So in this case, I'm training on a P3 2x large. So this is our latest, the P3 series is our latest series for machine learning training. They have great GPUs. They've got Tesla V100 GPUs in them. They're really beefy machines. And I'm using the least powerful of the current generation. And it costs about $3 an hour in order for training. Now, keep in mind, that's $3 an hour while it's training. It's not $3 an hour right now, right? I'm not using this instance yet. This is just me having my notebook instance running, which was just a T2 medium, so which is much, much, much cheaper. Finally, we're going to do something called setting some hyperparameters. So this is just jargon. I so wish the field did not call these things hyperparameters, because when I was first learning, I heard this and I was like, I don't feel smart enough to know what a word like hyperparameter means. It's just, all it means is other data that you need to configure in order to train your model. I wish they called it configuration, because that's really what it is, right? But I guess they were like, well, the images that we're using to train our model are the parameters. When I say they, I mean the deep learning community at large, right? Because this is not an Amazon term. But so we already have the images are the parameters for our model. So surely the data about how we're training it should be a hyperparameter. I don't know. Think of it like configuration, because that's all it is. So just looking backwards, what you can see here is I'm forming two dictionaries here, one with some base hyperparameters. So use pre-trained model true. What is this? This is, one for true. This is the key magic here to being able to build an image classifier without having a lot of data. So this is going to let us use a technique called transfer learning. All transfer learning means is take a machine learning model that was already trained on how to recognize a whole lot of different types of images, like what recognition has, right? So take that model already, which is trained on lots of data, which means the model already knows there are things like faces, not faces, but like, it knows how to detect edges in images. It knows how to detect curves and color contrasts and gradients and repeated patterns and things. And from that, it knows kind of like how to, that text might be a thing, or it knows how to see like our eyes see, basically. But take away all of the classes that model was trained on. So it keeps all the smarts about understanding the data, but get rid of that final layer that says, here's the smarts, and instead retrain just that last little bit on what my classes are. And so this lets you leverage really powerful models that have already got built, but with your own data instead. Here's where I'm specifying the image shape. Here I need to also just tell it how many total classes am I training with and how many total training samples amongst those classes did I have. And you can see up here, I just used some shell scripting to pull that data from the files that we already created. Finally, here's some things we might want to tweak. So you might hear people talking about hyperparameter tuning or model tuning. What they mean by that is after they train a model, they go back and they mess with some of these hyperparameters and they train the model again. So things like learning rate and mini batch size, these are both jargon in the deep learning world, and they describe things like how many images at a time should I be looking at before I kind of retrain my network. And it does this many, many times over and over and over again. Again, if we have more time after I show you the demo, I'm happy to get into this more. Same thing, learning rate is like, how much do I kind of sort of adjust my brain by when I'm trying again each time. So these are magic numbers, if you were. And how did I know to put these numbers in? Well, there are some defaults that you can start with. You don't even need to pass these numbers in. And the defaults are probably fine for a number of use cases. But we have a tool also called hyperparameter optimization, or automatic model tuning in SageMaker, where you can ask SageMaker itself to try a whole bunch of values for the hyperparameters that you care about in a lot of different permutations, and it will try and hone in on what numbers are going to give you the best model. And so you can do that as well. And that's how I got these numbers myself. Finally, we're just going to tell the image classifier, use the hyperparameters that we specified. And I just wanted to show you them all here, concatenated together. And then we say start the training. And here's where we prayed to the demo gods that everything went well. So I'm basically just making a training job name of IC our data set name and the timestamp. And now here's the magic line. This is where we say, hey, image classifier, fit. This means make our model using the inputs we specified before. I'm giving it a job name here, so it looks nice in my SageMaker console, and I want to see the logs at the end. And then I'll pull some information about the job to print out at the end. And so here we go. We're going to get this big wall of text here. Does SageMaker do distributed training out of the box? Asks Ardumu. I'm sorry, I can't pronounce your whole screen name, but yes, the answer is yes. And that's one of the things that makes it so cool. So look at these logs. I'm not going to read every log line here because we don't have enough time. And also that's a totally different kind of stream that would probably only interest a few people. But what you can see here is it has a bunch of preamble stuff where it says, okay, I'm getting ready to work. And then here's the interesting stuff. We can start seeing each epoch. So each epoch is like a restart of the whole training cycle where it's going to see how good it is. And we can see after the first time it ran, it was only 53% accurate. For the training data. And then it went in and tried to validate it. And even on the validation data, it was 92% accurate. So that's not bad. But it said, let me try again. And so then the second epoch, it was 90% accurate on the training data, and it was 100% accurate on the validation data. So even on just the second loop through, it was already like, yeah, I'm pretty good. And then it tries a bit more times, and you can see here that the numbers will change a little bit. And finally, at the very end, it'll say, okay, I'm done. I finished training. I've uploaded my trained model to S3. And if we wanted to, we could go to this S3 location and we could download this model.tar.gzip and we could inspect the data ourselves and we could use that somewhere else. But we're not going to do that. We're going to have SageMaker deploy instead. So I asked it to deploy me a model. And it looks like it's just finishing deploying right now because I don't have a timestamp yet. This cell is still running, but it should be done any second now. Yep. Look at that. That's perfect. I could not have planned that better myself. So it's done. It made me a model. So what I did here, it made me an endpoint. I said, after you're done training, image classifier, deploy, right? Make me a place where I can use this model from other code. And the neat thing here, again, is I said, I only want to start with one instance type for my deployed endpoint. And this does not need to have a GPU either. It can, and you can even attach GPU elastically using elastic inference to some of these things. But we don't need to. We can just use the really, kind of a low CPU powered machine here, or relatively low anyway. So we're using a T2 medium instance type in order to host our model at an HTTP endpoint. One last thing I wanted to mention before we look at the demo is check this out. The billable seconds for this training job was 196. Now, a P3 2x large costs 306 cents an hour, $3.06. Now, that's per hour, so divided by 60 is our per minute cost, divided by 60 is our per second cost, times 196. Right? That's 16.6 cents. That's how much money it cost us to train the model. That's it. 17 cents. That's amazing. That's the power of the cloud, right? It does not even cost a lot to do some of this work. But enough of that getting all excited. Let's see if this actually works. And this is where we cross our fingers, pray to the demo gods, and see how our model works, our endpoint works. So let's copy this model name, this endpoint name rather, and let's go to my second tool that I built. So this is just another little web app that I can say, here's my SageMaker endpoint name, here's where it's located, and the classes that we used when we trained, I just remember them. They were face and soda and marker. These should be alphabetized. Okay, moment of truth. Let's see. I'm going to take a picture of my face and we're going to say classify and see what happens. Okay, let's see. Face. Woo! So it says face, and I don't know if you can see this color gray on the stream. It's 99% confidence score that it was a face. And we can open this up and I can see what the other scores were. So it's definitely confident, didn't think it was a marker or a soda. So that's pretty cool. Let's try some other ones. So I also wanted to train with things it didn't see before. So I did not train with this purple marker. So it only trained with the green, the blue, and the red marker. So let's try this marker here. I'll do a couple because why not? Oh, I have to click here on this one. We can even try some that we already took pictures of. We'll do a few. And we'll do some soda cans while I'm just here. All right, let's see how these all did. Marker, 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 marker. Marker, 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 marker. All totally correct. Soda, soda. So yeah, like this model is doing great. It's super confident on all of these, 91% or higher. And again, this was only 30 images of each class. That's nothing, right? You can find 30 images of probably whatever you want out in the world. So you can do this today with this notebook and build a model that will do whatever you want. So how can you run this website? This website is another just a web tool that I built. I'm hosting it locally. It's just a web tool built with JavaScript and React. But the repo I will share at the end of this session. It's also in the notebook, so I could show you in the notebook if you clone it. At the end, I have a great resources to continue your deep learning journey. And inside here, here's both the webcam S3 uploader tool that I showed you before and the SageMaker inference web tool that you just saw. So you can clone those as well if you want to play around with them. They take a little bit of setup work in order, just like you have to, run a couple commands on your machine. If anything is confusing, if you try using these and you're not sure about how to get it up and running, open an issue on GitHub. Ping me if you want on Twitter. My handle is Gabe Hollenby. And I will absolutely help you out, right? That's what I'm here for. And again, I would love to. So that's cool. Can I take a photo with the marker in front of my face, please? Sure, CK. That's a great idea. Let's see what happens. I love it. Let's do it. Okay. So let's do Green marker because your screen name comes in green to me. Right in front of my face, like what, like that? Let's do that. I'll do a few because I don't really know exactly what you're going to think is happy. So we'll put one with both. We'll do one a little bit further back. And then we'll do one really close. Okay, I've done 3. Okay, so marker in front of face. It thinks face, and that's because look, if you notice, it's only 0.55, it's 55% confidence score, which is interesting, right? Now, what I'm curious about is what was the score for marker here? The marker was 0.1, and so does 0.2. So in this one, it doesn't know how to do that one. But this also makes sense, right? Because we didn't train with data that was dirty enough for it to know, how should it answer in the case where there's both a marker and a face in the middle. But here's one where the face is clearly visible and the marker is clearly visible, and it decided face was the highest score at 82% confident. Marker was the second highest one at 11%. Here's face again with 77%, and in this case, marker was actually lower than soda. So again, it's important to call this out too, because we can talk about a few things here. You want a variety of data, a variety of good training samples in your data, as obviously if you could, but which we didn't have that much variety. I mean, we had me and Ash do faces, and that's probably enough that, actually even with just my face, it's probably enough that it would recognize Ash, even though she looks very different to me. But let's talk about faces in particular. The more types of faces you can put into your training data set, the less bias you're going to have, right? I mean, there was a really famous example where a certain company had a tool out there that would try and automatically recognize, what was in your images, and it saw photos of people with dark skin and said gorilla. And it was terrible. And that's because they didn't, probably, I don't know for sure, but probably because they didn't have a varied enough training set of faces when they were teaching that model about what do humans look like. In fact, we're all shapes and colors and sizes, and that's something that's so beautiful about us. But again, if you're not thinking about that when you're training the model, it's not going to just know that. It's only as good as the data we give it. How will this work with scan images, said Amintara? I think it should work fine with scan images. An image is an image. The other answer would be, give it a shot. You have access to this notebook. It's not very expensive to try an example on your own, right? It took us 16 cents to train this particular model. So go ahead. Do I know about the algorithms in these libraries? I know a little bit Valyrian Steel, and the other people on the stream will also probably know some. So please feel free to ask away. Also, I like your screen name. I want to show you one more thing before we wrap up, at least. So we just did a demo of all of, a few very distinct classes, right? A face looks very different than a marker, looks very different than a can. What about things that are crazy similar? So I'm a bird watcher, I showed you. And if we look at, for example, there's a nice website here called Project Feeder Watch, and this encourages people to set up bird feeders in their backyard, see what birds come by, and report it online. And they have a section here, if you look in the Learn section, they have a section here called Tricky Bird IDs. And so these are birds that look pretty similar. And I went here and I said, okay, for my demo, I want to find birds that look really similar. Okay, sure, these two different birds, they look sort of similar, but like one is obviously super yellow and one isn't here. So that's but wait, these sparrows look really, really similar. So let's look at them in a little bit more detail here. These are two different types of birds here. These are two different types of sparrows, but they look damn similar. And so I thought, why don't I train a model to see if it can tell the difference between these really similar birds? In order to do that, I went here to learn more, and I looked at each of these birds. They have these little detail pages, for example, and you can see there's a number of images from each bird. And in fact, there's this lovely website put out or hosted, I think, by the Cornell Laboratory of Ornithology. Yep, I call the Macaulay Library. And so, for example, there's 17,000 images of this particular type of American tree sparrow, and there's many thousands of the other type. And if you log into this website, you can click the Save Spreadsheet button and get a CSV of the first 1,000 images here, and the URLs for them. And so I used those. I didn't use 1,000. I decided I'm only going to use like 450 images of each bird. And I trained another model. And I want to show you what that one looks like because it's really cool. So I'm going to go back to SageMaker. I'm going to look and see what my other model endpoint was. It's called Tree Chipping Sparrows. Let's go back to my little web app here. Let's get rid of all these images. Let's point it at my other endpoint name. And the two bird classes were American Tree and Chipping Sparrow. Okay, and instead of taking webcam pictures, I'm going to drag and drop some images from my Mac here. So let me bring this folder into view so you can see it. All right, so here are folders with images that the model never saw. These are not from the training or the test set. These are images that I did not use at all when I trained the model. And let's just take like the first 30 here. These are all American tree sparrow images. And I'll drop them on here, and we'll see how this model does. As you can see, it's saying very confidently these are all American tree sparrows. While we're waiting for those to finish, let me just get ready and drop some of the other class on. So those were American trees. Let's look at chipping sparrow. I'll just take the first 30 here. And let's look at those two. So the first 30 of these should all be American tree, and I think they are. And then let's go look and see what the chipping ones are. Yep, look at that. Chipping, 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 chipping sparrow. Okay, so look, here's one I got wrong. American tree. But look, notice it was only 59% confidence score. So relatively low. And this leads me to another thing, which I would say is when you're doing detection, scoring with your model, it's important to look at this because you don't just want to say, give me the one with the highest score and that must be it. You need to look at what that confidence score is before and take that into your business decision making, right? But without having to do the math ourselves, I'll just sum this up for you. I mean, look, it did really well. All the other ones in this quick test, it got right. In this model that I trained about these two extremely similar looking sparrows, I trained it with 450 images of each bird. And then I tested it with 100 images of each bird that it never saw before. And it was 97.5% accurate, which is amazing. And if you look at the ones that it got wrong, some of them are ones that I don't think a human could get right either because it was like a really blurry image or it was like a bird with its wings open and you couldn't even see some of the distinguishing characteristics of the bird at all because its wings were, it was like in flight. So the model did extremely well with that much data. Just to make it similar to the other one I did, where I did only 30 images of each class, I tried it with only 30 images of each sparrow, but because they're so similar, it didn't give me a great model. That model only performed at about 80% accurate. Still extremely impressive that it could be 80% accurate. That's 30% better than chance, right? Than just guessing with only 30 images of each class. So this stuff is really powerful, and I encourage you to experiment with it and play around with it in your own learning journeys. Okay, so Kakurati, yes, there are some that will say confidence 1. That's probably a floating point rounding error because there's math that happens on the back end in order to finally create a confidence score. There's no such thing as true 1 or true 0, right? It's all going to be a gradient and a range. Can you write your own models, Aurora? Yes, you can. Thanks, Nikki. I'm looking to see if there's any other questions we want to answer in the time that we have. Soundmaster, you want to do one with bird call audio? It's a question I have too. I haven't looked into it yet, but what I would say is there are some algorithms and techniques that are made for translating text, right? So in text, automatic machine translation, like Amazon Translate, which is our full service API. So if you don't want to train your own model to translate Japanese to English, for example, or English to Japanese, or Spanish or whatever, you can use Amazon Translate. The concept is similar to a bird call, right? If you quantize any kind of digital signal, you get effectively a series of things that say, at this point in time, I had this frequency, right? This next point in time, I had this frequency. You could think of that like a sentence, right? And the meaning of the sentence has to do with the words in the sentence and where they are in relation to each other. So I haven't tried this yet, and I'm not a machine learning powerhouse expert here, so this might not work, but my naive thinking is you might be able to use this similar technique, which is called a LSTM, which is confusing. It stands for long short-term memory networks. And these are networks that actually remember more than just the current thing you feed them, but what they saw just before and what they saw just after, or for some configured range, because that all relates to what it is. So you might be able to use a algorithm that's trained with that sort of technique in order to recognize bird calls. Please, if you learn more, let me know what you end up with. I'm super keen to find out. Any other questions? Are there several types of ML algos? It says XYZ. Yeah, let's just go look at that once again when we wrap up. So back in the SageMaker docs, yeah, that's not the SageMaker docs. This is. If we go here to looking at the built-in algorithms, we can see that, well, first of all, we can just see them right here, right? There's one called blazing text, one called deep AR forecasting, one called factorization machines, image algorithms, IP insights, k-means, k-nearest neighbors, latent Dirichlet allocation, linear learner, neural topic modeling, object-to-vec, principal component analysis, random cut forest, XGBoost, sequence to sequence, etc. So, semantic segmentation. So these are the ones that come built into SageMaker today. We, are often adding more built-in algorithms, and you don't have to use a built-in algorithm. If you know a bit more about deep learning and you're comfortable making your own network that just needs to get the data passed into it, you can do that. You can package it up in your own Docker container, and you can pass that to SageMaker to use for training as well. And there's, of course, there's documentation about that too, using your own algorithms. So you can find a number of resources online, both from our own documentation and elsewhere, that will guide you through that as well. We need to wrap up. We're right at the end of time. And so again, I just want to leave you with the following. I didn't really talk about what customers are using SageMaker. Check this out really quickly. Hotels.com, they are able to say which images of a hotel room looks the nicest and is going to encourage people to book. Intuit, I love them. They spoke at reInvent, our big conference that we have every year in November, just this last November. And the head of data science for Intuit came up on stage and she shared how using SageMaker, they took their machine learning training workloads that used to take 6 months, and now it takes them a week. So that's amazing, right? 90% faster model training. So you can see more about that here. There's a lot of other customers that will inspire you to hopefully do cool things. Again, in terms of resources, please look at the notebook at the last cell here for more. I can't stress strongly enough, you should look at 3 Blue 1 Brown's YouTube series. It's 60 minutes. It'll be some of the best 60 minutes you spend in terms of learning how these things work, how neural networks get trained, what they're all about. Please also check out Amazon Machine Learning University. This is an exciting new thing where now we took a lot of the internal training that we use at Amazon and AWS to teach our own developers into becoming machine learning practitioners, and we put it all online for free. So you have access to that today. It's really amazing content. I strongly encourage you to look at it. All right, that's it. You all have been a wonderful audience. Action, I don't have time to answer your question now, but I'm going to be doing another stream later this afternoon, my time. And so if you want to come back and watch us again and ask a question, then I'd be happy to answer it for you. It's at 1:30 Singapore time. That's GMT +8. Okay, thanks so much. Is there a link to these resources? Yes, we'll paste the link one more time into the chat for you. I can ask one of the moderators to do that. Really, really, really thank you. You're awesome. I hope this inspired you to build something cool, and if it does, please let me know. It really makes my day when I hear about what everyone out there is doing with AWS, and hopefully what I inspired you and taught you today. So thanks again. This is Gabe Allenby signing off. See you next time.